myopia, 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 myopia. For that correction we are using bro. What bro? Myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, hypermetropia, 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 hypermetropia. For that correction we are using convex lens, hypermetropia, convex lens, myopia, concave lens. New Cartesian and convention are the distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian and convention, all distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative to the principal axis. New Cartesian and convention, Say with me, learn with me, sing with me. Dispersion, splitting white light into 7 colors is known as dispersion. Splitting white light into 7 colors is known as dispersion. The phenomena splitting light into constituted colors. The phenomena splitting white light into 7 colors is known as dispersion. The band of colors is known as spectrum. The phenomena, emission of light in all directions with a different intensity is called scattering of light. So, hi everyone, welcome to the Student Brand. This is our Shiva sir. Hi everyone, welcome to the Student Brand. This is our Shiva sir. Today we are going to discuss about electric current. Hi, Brown. Welcome to the student. So this is our semester. Today we are going to discuss about electric current. Electric current is nothing but the rate of flow of charge I equal to Q by T. Electric current. Electric current. Electric current. So I equal to Q by T. I equal to Q by T. I equal to Q by T. I'm taking I equal to Q by T. So SI unit of electric current is SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of electric current is ampere. SI unit of charge is coulomb. So I am taking here SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. And SI unit of time is second. Second I am considering here. Okay, SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. So I equal to Q by T. I equal to Q by T. So the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. So the rate of flow of charge is called electric current. I equal to Q by T. I am taking I equal to Q by T. Rate of flow of charge. Rate of flow of charge. So 1 ampere is defined as 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. Electric current. I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So I equal 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Unit cross section area per second. Unit cross section area per second. So that is nothing but 1 ampere. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. And now, so charges will move inside of the conductor. Charges will move inside of the conductor. Either plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So there are number of charges will move inside of the conductor. Number of charges will move inside of the conductor. Okay, so it won't be 1 or 2. So there are integral multiple. Integral multiple charges will move integral multiple. Integral multiple will move. So that is the reason we are considering quantization of charge. So that is nothing but plus or minus Ne. Sir, why you are taking plus or minus Ne? So why can't we go for another? So why you are taking plus or minus in the sense? Plus or minus in the sense. So the positive charges will be there, negative charges also there. Positive charges will be there, negative charges also there. Positive charges are there, negative charges also there. That's why we are taking plus or minus Ne. Plus or minus Ne. So we are taking plus or minus Ne because positive charges are there, negative charges are there. So charges are moving inside of the conductor. And if you are taking on one electron, we are considering 1.6 into 10 power minus 19 coulomb. On one electron, how much charge is present? On one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb. Okay, so in one coulomb, if you are taking 1 coulomb, in 1 coulomb, so how much charge is present? So you can consider here, you can observe here. Okay, so I'm considering in 1 coulomb, so 1 by 1.6 into 10 power minus 19. Okay, so if you are taking 1 coulomb equal to 1 by 1.6 into 10 power 19, then you will get 1 by 1.6 into 10 by 10 into 10 power 19, then 10 by, so 16 will get 10 power 19, then you will get, so 10 by 16 is how much? 10 by 16 is how much? 10 by 16 is, So 0.625 into 10 power 19. Then if you solve it, 6.25 into 10 power 18 electrons. So 10 power 18 electrons are present. So in 1 coulomb 6.25. In 1 coulomb 6.25 into 10 power 18 electrons are present. In 1 coulomb. Okay, so in 1 coulomb 6.25 into 10 power 18 electrons are present. So electric current. Electric current is nothing but rate of flow of charge. Electric current is nothing but rate of flow of charge. Electric current is nothing but rate of flow of charge. So I equal to Q by T. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of second. So 1 ampere is defined as 1 coulomb of flowing through unit cross section area per second. So number of charges will move inside of the conductor. It won't be one or two, like number of integral multiple. Q equal to plus or minus NE. So I'm taking Q equal to Q equal to plus or minus NE. Q equal to plus or minus NE. So on one electron 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb is there. So in 1 coulomb, how many electrons are present? In 1 coulomb, 1 by 1.6 into 10 power minus 19. 1 by 1.6 into 10 power 19. So 1 by 1.6 into 10 by 10, that is 10 power 19. So 10 by 10, 16 is 10 power 19. So if you are taking this value, if you solve this, you will get it 0.625, that is 10 power 19. 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons are present. So this is about electric current. This is about electric current. Okay, so this is about electric current. We are discussing electric current. Now, so we'll discuss about more electrical appliance. We'll discuss about electrical appliances. Electrical appliances. I'm considering electrical appliances. Those are electrical appliances. Those are cell. First one is cell. Positive terminal, negative terminal cell. So second one is battery. Cell. Battery. Positive terminal, negative terminal. Battery I'm taking. Positive terminal, negative terminal, battery. So third one, cell, battery. Next one, open switch. I'm taking this open switch. So fourth one is closed switch. Fifth one. So open switch and closed switch, cell, battery, open switch and closed switch. Next one, resistor. And the sixth one is rheostat. Either like this way or this way also we can take rheostat. Resistor, rheostat, closed switch, open switch, battery, cell. Okay, next one. Seventh one, ammeter. Ammeter. Eighth one, voltmeter. 10th one. Ninth one. Ninth one. Ninth one. So ammeter, voltmeter. Wire joining. 11th. 10th one, wire crossing. 11th one. 11th one. So 11th one is bulb. 11th one is bulb. 11th one is bulb. 11th one is bulb. Cell, battery, open switch, close switch, resistor, rheostat, ammeter, voltmeter. So switch, this wire joining, wire crossing, bulb. Wire crossing, bulb. Okay. So this is about electrical appliances. Electrical appliances. So next we will discuss about these are electrical appliances. These are electrical appliances. We'll discuss about electric current, electric circuit, electric circuit. Electric circuit. Next one is electric circuit. Electric circuit. Electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. So I'm considering here. This is the cell. So switch. So I'm considering ammeter. This is a bulb, and I'm considering here. So positive terminal, negative terminal current is flowing. So here bulb is glowing, bulb. So you can observe a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is an electric circuit. So there are two types of current: conventional current and electric current. Conventional current, conventional conventional current and electric current. So second one is electric current. Conventional current and electric current. Electric current. Conventional current and electric current. Conventional current is nothing but the flow of positive charges. Conventional current. The flow of positive charges is known as conventional current. Positive charges will move from positive terminal to negative terminal. Positive terminal to negative terminal. Electrons, negative charges will move from negative terminal to positive terminal. Positive charges will move from positive terminal to negative terminal. Electrons will move from negative terminal to positive terminal. Positive charges high potential. Positive charges high potential, whereas negative charges low potential. Low potential. Positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential, low potential to high potential, low potential to high potential. Electrons will move. Positive charges will move from high potential to low potential. High potential to low potential. Positive charges will move. Electrons will move from low potential to high potential. High potential. Conventional current. Conventional current. The flow of positive charges is considered as conventional current. The flow of positive charges will be considered as a conventional current. Electric current. Flow of electrons. Flow of electrons will be considered as electric current. Electrons will move from low potential to high potential. Conventional current. Conventional current. Positive charges will move from high potential to low potential. High potential to low potential. Electrons will move from low potential to high potential. Conventional current. Conventional current. Conventional current. Conventional current. Conventional current is positive charges will move from low potential to high potential. Electrons will move from low potential to high potential. Next we are going to that. So here this is about conventional current and electric current. A continuous and closed path of an electric current is known as a conventional current. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of a continuous and closed path of a continuous and closed path of an electric current is known as electric circuit. Electric circuit. Electric circuit. Now, so listen carefully. Next, I am going to explain about potential difference and electrical potential. Potential difference and electrical potential. So electric current. Next one, potential difference. Potential difference. Be ready. So I'm taking potential difference. Potential difference. Yes or no? Potential difference. Work done to bring unit positive charge. Potential difference. Potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point. One point to another point. One point to another point. One point to another point is known as potential difference. Potential difference here we are doing. So I'm considering here, I'm taking here. This is the point A and this is point B. So we are taking the charge. Yes or no? Yes or no? We are taking the charge. Positive charge. We are taking the charge. Positive charge. We are doing some work. We are doing some work to bring the unit positive charge. Unit positive charge from one point to another point within the conductor. One point to another point. Yes or no? We are doing some work to bring unit positive charge from one point to another point within the conductor. So I'm taking here. We are doing some work. We are doing some work to bring the unit positive charge from one point to another point is called potential difference. Potential difference. Potential difference. V equal to W by Q. V equal to W by Q. V equal to W by Q. W is the work done. W is the work done. 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 Potential difference is equal to work done to bring unit positive charge from one point to another point. From one point to another point is known as potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. Yes or no? Potential difference. So SI unit of potential difference is SI unit of potential difference is SI unit of potential difference is volt. Volt. SI unit of potential difference is volt. 1 volt equal to SI unit of work is SI unit of work is joule. SI unit of work is joule. SI unit of charge is coulomb. SI unit of work is joule. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. Work done to bring unit positive charge from one point to another point is known as potential difference. Potential difference. Potential difference. Potential difference. Work done to bring unit positive charge from one point to another point within the potential difference. Potential difference. Potential difference V equal to W by Q. That is volt. SI unit of potential difference is SI unit of potential difference is volt. SI unit of work is joule. SI unit of charges coulomb. So we are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 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 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point is known as potential difference. Potential difference. Potential difference. Yes or no? So that is about potential difference we are considering here. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. 1 volt is defined as 1 joule of work is done to bring 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Electrical potential. 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 Electrical potential is nothing but work done to bring unit positive charge from one point infinity to the required field. Infinity to the required field. This is the required field. So this is the positive charge. We are doing some work. V equal to W by Q. W by Q work done to bring unit positive charge. Work electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field. From infinity to the required field. from infinity to the required field, from infinity to the required field. Potential difference work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point, from one point to another point, from one point to another point within the conductor. Is known as potential difference. Okay, so that is about potential difference. Electrical potential in nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field. From infinity to the required. Infinity to the required field. From infinity to the required field. From infinity to the required field. From infinity to the required field. That is called electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential, electrical potential. Right? Next. Ohm's law. So what is Ohm's law? Ohm's law is nothing but so we can take. So I'm considering this the resistor. This is called switch. That is closer switch. Resistor I'm taking. This is a resistor, and this one is the switch. Closer switch. What is the switch? Closer switch. And across this one, we are connecting voltmeter. What is that? Voltmeter. Yes or no? So this is ammeter. What is this one? Ammeter. What is this one? Ammeter. I'm considering here. So there are four cells. Positive cell, negative cell, positive, negative. 1, 2, 3, 4. There are four cells. Those are you can consider here. There are four cells. Each cell potential difference is 1.5 volts each. Each cell potential difference is 1.5 volts each. Now we are going to discuss about Ohm's law. What is that? Ohm's law. So what is that? Ohm's law. So I'm considering here current is flowing from the battery. Current is flowing. Yes or no? From the battery, current is flowing, right? So here, I'm considering here, so current is passing from battery, right? Yes, here I'm considering this is a positive cell and negative cell. There are four cells. I'm considering. 1, 2, 3, 4. 1, 2, 3, 4. There are four cells. Each cell potential difference is 1.5 volts each. Each cell potential difference is 1.5 volts each, right? Yes or no? Current is start flowing from the battery through the ammeter, voltmeter. So voltmeter, and this is the resistor. I'm considering this is a resistor, across resistor, the potential difference. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V equal to IR. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. Is called it's called Ohm's law. What is Ohm's law? The potential difference across the ends of the metallic conductor is directly proportional to current flowing through it at constant temperature. And also physical conditions are same. And also physical conditions are same. But actually at constant temperature, the potential difference across the ends of the metallic conductor given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to I. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. V equal to R equal to V by I. I am considering here. Now you can observe V equal to R equal to V by I. Come on, R equal to V by I. 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 What are the materials required? Now we will discuss about materials required. Materials required. Those are 4 cells, 1.5 volts each, and nichromere is an alloy of nickel, chromium, manganese, and iron metals. So ammeter, voltmeter, ammeter, switch I'm taking, connecting wires. These are the materials required. Once again, what are the materials required? Ammeter, voltmeter, 4 cells, 1.5 volts each, and nichromere is an alloy of nickel, chromium, manganese, and iron metals. And connecting wires. Ready? Are you ready? Be ready. Now I'm considering materials required. Materials required. What are the materials required? Materials required. Materials required. What are the materials required? First one is 4 cells, 4 cells of 1.5 volts each. Second one, 4 cells, 1.5 volts each, and nichromere is an alloy of nichromere. Nichromere is an alloy of nickel, chromium, manganese, and iron metals. Nichromere is an alloy of nickel, so 0.5 meter. And the next one, third one, ammeter. And fourth one, voltmeter. And fifth one, connecting wires. Connecting wires. Ohm's law. What is Ohm's law? It is Ohm's law. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. At constant temperature. So how many cells? 4 cells. 1.5 volts each. Nichromere. So nichromere is an alloy of nickel, chromium, manganese, and iron metals. Ammeter, voltmeter, and connecting wires. May procedure. What is the procedure? The procedure is first you have to take one cell and to note down the reading of ammeter and voltmeter. First you have to take the one cell. You have to connect one cell in the circuit. You have to connect one cell in the circuit and note down the reading of ammeter and voltmeter. You can observe here. First you have to connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Next connect two cells. Connect two cells. Second one connect two cells. Two cells. Two cells and note down the reading of ammeter and voltmeter. So third one connect three cells and repeat the process for 3 and 4. Repeat the process for 3 and 4. So repeat the process for 3 and 4 once again. First you have, so what is Ohm's law? Ohm's law is nothing but at constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. At constant temperature, potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. I V equal to V is directly proportional to I, V equal to I R equal to V by I. So materials require 4 cells, 1.5 volts each. Nichrome wire. So this here 1.5 volts each. 1.5 volts each. 1.5 volts each. 1.5 volts each. And 1.5 volts each. Yes or no? Yes. Here I am taking 1.5 volts each. There are 4 cells I am considering. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And ammeter, voltmeter, connecting wires. So procedure, what is the procedure? We have to do it. The procedure is you must connect one cell and note down the reading of ammeter and voltmeter and mention in the tabular form given below. Next you have to connect two cells and note down the reading of ammeter and voltmeter and mention in the tabular form given below. Next repeat the process for 3 and 4 cells. Next, repeat the process for 3 and 4 cells. Now, you can draw the graph for VI. If you draw the graph for VI, it will be linear starting from origin. It is a linear line starting from origin. This graph is for only comic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductor. The substances, the conductor which does not obey Ohm's law, those are called non-ohmic conductors. Conductors which obey Ohm's law, those are called ohmic conductors. Conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductor graph you observe now. I am taking now here non-ohmic conductor graph. Here V on y-axis, X on y-axis. The graph is curved. Yes or no? Yes or no? Let me know. Is it clear or not? Is it clear or not? You need to understand one thing. Ohm's law is nothing but the potential difference across ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. Be very clear, be very specific about the definition. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. That is Ohm's law. What are the materials required? 4 cells. 1.5 volts each. 4 cells, 1.5 volts each. And nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, connecting wires. These are the materials required. And switch also we have to consider. These are the materials required for doing activity. What is the procedure? Procedure. What is the procedure? The procedure is you need to connect one cell first. You need to connect one cell first in the circuit and note down the reading of ammeter and voltmeter. Ammeter reading and voltmeter reading you have to mention. After that, you have to connect two cells. Two cells and note down the reading of ammeter and voltmeter again and repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention in the tabular form given below. Mention in the tabular form given below. You have to mention in the tabular form given below. This is the tabular form. This is the tabular form. This is the tabular form. So if you draw the graph for VI, if you draw the graph for VA, so V is directly proportional. So the graph will start from origin. So it will be linear. It will be linear. So that is for ohmic conductors. Ohmic conductor. Ohmic conductors. Ohmic conductor. What are the ohmic conductor? The conductor which obey Ohm's law. The conductor which obey Ohm's law. Those are called ohmic conductors. The conductors which obey Ohm's law. Those are called ohmic conductors. The conductor which does not obey Ohm's law, the conductors which does not obey Ohm's law, the conductors which does not obey Ohm's law, those are called non-ohmic conductors, non-ohmic conductors, non-ohmic conductors. Yes. So conductors which obey Ohm's law, those are called ohmic conductors. Conductors which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. Yes or no? Yes or no? Non-ohmic conductors. I hope it is very clear about it. So right. So we'll discuss one more. We'll discuss one more. That is about Ohm's law. So just a little break. Little break. I'll drink water and come back. Resistance. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit is known as, already said, resistor. Resistance is the phenomenon of opposing the electric current. Resistance is the phenomenon of opposing the electric current. Yes, a unit of resistance. 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 Ohm. Ohm. Yes, a unit of resistance is ohm. Yes, unit of resistance is ohm. Now you are considering. So resistor is a device. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Yes. R is directly proportional to L by A. R equal to rho into L by A. L by A. R equal to rho into L by A. L by A. L by A. Yes or no? R equal to 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 rho into L by A. R equal to rho into L by A. R equal to rho into L by A. Yes or no? R equal to rho into L by A. Resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Here R is the resistance. R is the resistance. R is the resistance. Rho is the resistivity. Rho is the resistivity. Rho is the resistivity. R is the resistance. Rho is the resistivity. R is the resistance. Rho is the resistivity. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistivity. So very very important. Very very important 2 marks question. 2 marks question. SI unit of resistivity. SI unit of resistivity. SI unit of resistivity. Rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Rho equal to ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Ohm meter. Now you are considering resistance. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R equal to rho into L by R equal to L by R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by R equal to rho into L by A. So rho equal to RA by L. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Meter get cancelled. Meter get cancelled. So rho equal to ohm meter. Rho equal to ohm meter. Ohm meter. Your rho equal to ohm meter. SI unit of resistivity is ohm meter. Understood? Is it clear? Is it clear? Right. So now we can see. Now we can see. This about resistance and resistivity. Now we'll discuss about differences between resistance and resistivity. Difference between resistance and resistivity. So here you can observe. I am considering resistance and resistivity. Resistance is equal to RL by A. Resistivity is equal to rho. R resistance is equal to rho into L by A. Resistivity is equal to RA by L. Yes, I unit of resistance is ohm. Yes, I unit of resistivity is ohm meter. Symbol. Resistance depends on length and area. Resistivity does not depend on length and area. Length and area. Resistance depends on temperature. Resistance depends on temperature. Resistance depends on material. Resistance depends on temperature. Resistivity depends on material. Resistance. Yes, a unit of resistance ohm. Yes, a unit of resistance is ohm. Resistance depends on length and area of the conductor. Resistance depends on temperature and resistance depends on material of the conductor. Resistivity. Yes, a unit of resistivity is ohm meter. Yes, a unit of resistivity is ohm meter. Yeah, resistivity depends on temperature. Resistivity depends on material of the conductor. Resistance and resistivity. The difference between resistance and resistivity is very, very important. Very important. 3 marks question. Very, very important between resistance and resistivity. Everybody roll on this question. Very, very important. Resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Dun, 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 dun. So that is about resistance and resistivity differences. The difference between resistance and resistivity. Next we are going to discuss about a meter is used to measure the electric current. A meter is used to measure the electric current. Yes, the unit of electric current is ampere. A meter is connected in series combination in the circuit. Voltmeter is used to measure the potential difference. Yes, the unit of potential difference is volt. Voltmeter is connected parallel combination in the circuit. So that is about ammeter and voltmeter. What is the electric current? SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. Dun, 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 dun. Resistors are connected in series combination. Resistors are connected in parallel combination. Dun, 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 dun. Resistors are connected in. Resistors are connected in. Dun, 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 dun. So I'm considering current is flowing in the circuit. Ammeter, R1, R2, R3 resistor across R1, V1, V1, V1. I am connecting across R1, V1, 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 V1. Dun, 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 dun. Across R1, V1, across R2, V2, across R3, V3, V3, potential difference, V is directly proportional to I, V equal to IR. That is called Ohm's law. Remember. So current is passing here across R1, V1, across R2, V2, across R3, V3. Now enter the circuit, enter the circuit, in the circuit, current will pass, enter the circuit, current is same. In the entire circuit, current is same. In the entire circuit, current is same. I S equal to I1 equal to I2 equal to I3 equal to I. So I'm considering here current is same in the circuit. Current is same in the circuit throughout R1, throughout R2, throughout R3. All through all resistors. Only current, single current. So current is same. Current is same throughout. That's why IS equal to I1 equal to I2 equal to I3. Yes or no? Now you are considering here. Now you are considering. We are considering Ohm's law V equal to IR. V equal to IR. V equal to IR. V equal to IR. Potential difference is equal to potential difference across the ends of the metallic conductor is directly proportional to current flowing through at constant temperature. V is directly proportional to II. V equal to IR. V equal to IR. I'm considering now V equal to IR. R equal to. So here in this condition, in this case, when resistors are connected in series combination, when resistors are connected in series combination, when resistors are connected in series combination, that time we are considering Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3 because potential difference, potential difference potential difference across R1, R2, R3, across R1, R2, R3, the current is same, so that's why entire the circuit current is same. That's why I'm considering IRS equal to IR1 plus IR2 plus IR3. So we can take I common. IR is equal to I am considering common R1 plus R2 plus R3. I1. So we are taking I common R1 plus R2 plus R3. So if I consider, okay, so I get cancel. RS equal to R1 plus R2 plus R3. So the total resistance in the circuit RS equal to R1 plus R2 plus R3. You must add, if resistors are connected in series combination, you must add all the resistance. That's enough. That is about resistors are connected in series combination. Resistors are connected in series combination. Resistors are connected in series combination. RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. That is about resistors are connected in series combination. Resistors are connected in series combination. RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, RS equal to NR. RS equal to NR if n number of resistors are connected in series combination. If n number of resistors are connected in series combination, RS equal to NR. If resistors are connected in series combination, so total resistance is equal to RS equal to R1 plus R2 plus R3. N number of resistors are connected in series combination. This is the formula. RS equal to NR. RS equal to NR. RS this is about resistors are connected in series combination. Resistors are connected in series combination. Next we are going to the resistors are connected in parallel combination. Resistors are connected in parallel combination. Very, very important formula. So this condition is very important. This condition is very, very important. Condition very important. So 1 mark in exam. This question also very important. Formula is very, very important. RS equal to R1 plus R2 plus R3. Very, very important. And n number of resistors are connected in series combination and voltmeters. So potential difference is equal to IR. That is about Ohm's law. Ohm's law is very important in series combination. In series combination is current is same. This condition is very important. RS equal to R1 plus R2 plus R3. This point is very important. And RS equal to NR. RS equal to NR. Very good. This is about resistors are connected in series combination. Resistors are connected in series combination. So now resistors are connected in parallel combination. Hi everyone, welcome to the class. So thank you so much for being in the class and listening my class. So I'm very happy for you. So we'll continue. Still more two more topics are there. So we are saying hi everyone. Sorry, I couldn't able to say hi to everyone. So because due to time lagging. So what two more topics are there? We will discuss. Okay. So very important topics. Resistors are connected in parallel combination. Resistors are connected in parallel combination. So here, if you are considering, I'm taking three resistors. So here we can take resistors are connected in parallel combination. So in this condition, potential difference across R1, R2, R3, potential difference across R1, R2, R3. So same potential difference, same, but whatever the current is flowing, so that will be dividing into three parts I1, I2, I3. So that is dividing into three parts I1, I2, I3. So potential difference across three resistors is same. So from Ohm's law we can take, from Ohm's law, V equal to IR. From Ohm's law, V equal to IR, I equal to V by I equal to V by I am considering. I equal to V by R. I equal to V by R. Potential difference is directly proportional to IV equal to IR. That is nothing but Ohm's law. Here I am considering I equal to V by R. I equal to V by R. V by R. Vp equal to V1 equal to V2 equal to V3 equal to V. Why? Because potential difference is same across R1, R2, R3. That is the reason we are taking Vp equal to V1 equal to V2 equal to V3 equal to V. Yes or no? Now we are going to the next one. Here current is dividing. Potential difference is same. Current is dividing. Then we are considering Ip equal to current in the parallel combination is equal to I1 equal to I2 plus I3. IB equal to I1 plus I2 plus I3. IB equal to I1 plus I2 plus I3. That we are writing in this format. V by RP equal to V by R1 plus V by R2 plus V by R3. Now you can take V common. V is common in this case. V is common. You can take V common 1 by RP equal to V common 1 by R1 plus 1 by R2 plus 1 by R3. That is VB get cancelled. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Now you can observe here. You can observe. Are you observing or not? B is same across R1, R2, R3. B is same across R1, R2, R3. In parallel combination, the physical quantity is the physical quantity which is constant in parallel combination is the physical quantity which is constant in parallel combination is potential difference. Potential difference. The physical quantity which is constant in series combination is current. Current in series combination. The physical quantity which is constant. Current in parallel combination. The potential difference is constant. In parallel combination, potential difference is constant. That's why I'm taking V equal to V1 equal to V2 equal to V3 equal to V from Ohm's law. We are taking from Ohm's law, from Ohm's law, from Ohm's law. From Ohm's law, V equal to IR, I equal to V by R. Current in parallel combination, current in parallel combination, current in parallel combination, IB equal to I1 plus I2 plus I3, 3. What are the current? Throw that where the current is passing in the circuit. Throughout the circuit, if you want to find out the current is equal to, we need to add I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. From Ohm's law, we can write V by RP. V is common, we can take common. So VB we get cancelled. The remaining formula is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Potential difference. Now you can understand one thing. If resistors are connected in series combination, you must add all the resistance. In parallel combination, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is about resistor connected in parallel combination. Resistors are connected in parallel combination. Which combination? Parallel combination. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. Rp equal to R by n. Rp equal to R by n. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. Rp equal to R by n. Rp equal to R by n. This is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Everyone focus on this concept. Very, very important. Very, very important. Very, very important. Very, very important. Very, 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 very important. Very important. Very important. I hope it is very clear to you all. So next one we will go to the, so we are going to discuss about, yes. Heating effects of electric current. Heating effects of electric current. Heating effect of electric current. So potential difference is equal to W by Q. W equal to V into Q. So power equal to work done by time. So that is nothing but VQ by T. So I am considering here. Q equal to Q by T is current. I equal to Q by T. So P equal to, so V into Q by T. That is nothing but current. So V into I. So here we can consider energy. Energy is given to the conductor. So that is power into time. So whatever the heat, whatever the energy is given to the conductor, that will become heat. So then we can say P equal to VI, right? P equal to VI. So substitute VI into T. So V equal to IR. So H equal to IR into I into T. Then H equal to I square RT. So here heat produced in the conductor. Heat produced in the conductor. Okay. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So very important. So heating effect of electric current. So V equal to W by Q. W equal to V into Q. Q by T is I. P equal to work done by time. So that is nothing but rate of work. So we can see W by T, work done per unit time. So VQ, W equal to VQ by T. So Q by T is I. P equal to V into Q by T, VI. So energy is given to the conductor. That will be, so P into T. In the place of you substitute V, whatever the energy is given to the conductor, that will become in the form of heat. H equal to VA into T, H equal to IR into IT, so H equal to I square RT. So the total, the source of energy continuously gets dissipated entirely in the form of heat is called. The source of energy continuously gets dissipated. Entirely in the form of heat is called heating effect of electric current. Applications of heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. Applications of heating effect of electric current. So electrical geyser, we can say room heaters, iron box. So if you know the heating effect of electric current, please you can comment in the comment section below. So applications of heating effect of electric current. So I'll tell one example. So iron box, like a electrical oven, electrical cooker, and so we can go for room heaters. So these are examples for heating effect of electric current. If you know the answer, so you can comment in the section. So you can comment in the comment section below. Okay, next one, we are going to the one more point. Short circuit, the direct contact of lever and neutral wire takes place. The direct contact of lever and neutral wire takes place. That is called short circuit. And the next one, overloading. High voltage appliances on at a time. in the circuit, heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. High voltage appliances on at a time in the circuit, a heavy amount of current will be drawn from the mains. Then it leads to the short circuit. Okay. So, and coming to the fuse, fuse is a safety device which protect the appliances, electrical appliances in the circuit. Fuse is a safety device which protect the safeguard the appliances of electrical circuit, electrical appliances in the circuit, because whenever the current is going inside of the conductor more than its required limit, more than its required limit, more than its required limit, more than its required limit. So we can fuse will melt and break the circuit. So it's required 5 ampere is there. So it is in the circuit it is more than 7 ampere it's going. Then fuse will melt and break the circuit. Then it safeguard the appliances. That is the use of fuse. And so that is a safety device in household. So we are using. And next one earthing. So if extra current is there, that will send to the ground. Okay, so that is about earthing. So this is about we can say short circuit and overloading, short circuit and overloading, and heating effect of electric current also. So that's enough. That is about uh, chapter. Okay, so yes, so there are many questions related to my output. So I have to answer. So I can understand. So there are why this type of output, why you can teach normally. So I can understand because see, I'm doing from long back onwards. So from past nearly 8 years, 8 years onwards I'm doing. 8 years onwards I'm doing teaching. Okay, so before that, no, with this type of teaching. So before that onwards, for overall 10 years. So 8 years onwards, I'm doing this type of activities. You can see from 5 years onwards, nearly more than 5 years in YouTube, all the videos you can observe related to physics only. So I'm doing with the different kinds of teaching style. Okay, so with the different kinds of accepts. So if you like it, please do like and support my channel. So I need your support. I need your support. So this output is whatever I am wearing. So before the class, that is a part of the teaching. That's enough. Nothing else. There is no other things to do. So why I'm doing this part of the teaching. So to reach the students in a better way. So to make them to understand the concept in a better way. That's the reason. So it's a part of the teaching I'm doing. So if you like it, if you like my channel, if you like my explanation, please do like and share and subscribe my channel. So this is your Siva sir from Student the Brand. So there are many activities, many experiments. You can observe, you can check my channel if you want. So if you want more details or more things about, if you want to know, please go to my channel and check my channel. There are many videos, many experimental videos, many activity videos. Okay. So in a better way, in a best possible way, from my end, my point of view, I want to teach. So that's enough, nothing else. I'm just teaching. So concepts, physics, to make them understand, to make them to learn. Okay, so that's enough. If you like it, again I'm saying, if you like it, please do like, share and subscribe to Student the Brand. This is your Siva sir. Thank you so much. Please do like, share and subscribe and inform your juniors or seniors and your people who knows and who to whom it is useful this video. You can share and support my channel. I need your support. Thanks once again.